Our second look at ellipses is still continuing state standards 16 and 17, and our second look at ellipses includes general form. So again, for all of the conic sections, it's ax squared plus by squared plus cx plus dy plus e equals 0. For circle, remember a and b were same sign, same number. For parabola, either x squared was missing or y squared was missing. For an ellipse, two things. A and b must have the same sign. They are both positive or both negative. But a and b need to be different numbers. Now again, they can't be opposite signs, but they must be different numbers. If for some reason they were the same numbers, remember that would be a circle. So as we look at this equation, right now we're telling you it's an ellipse, but later we'll be just giving you the equation. You'll be telling us what it is. So when everything is on one side and 0 is on the other side, we look at the coefficients of x squared and y squared. Both positive, different numbers, it's an ellipse. So we're going to take the constant to the other side and complete the square twice. Once for the x's, once for the y's. So let's gather the x's together, let's gather the y's together. Let's complete the square. We have to factor out the 4, so that leaves me with x squared minus 4x. We have to factor out the 9, so that leaves me with y squared plus 2y. And we're going to do that Texas two-step twice to complete the square here. So for 4 divided by 2 is 2, 2 squared is 4, but this 4 is being distributed by a 4. So what I'm really adding to the left side of the equal sign is 16, and I must add 16 to the other side of the equal sign as well. For y, 2 divided by 2 is 1, 1 squared is 1, but that's being distributed by a 9. So I'm really adding another 9 to the left side of the equal sign and need to add a 9 to the right side of the equal sign. As we factor that, perfect square trinomials factors the square root of the first term, square root of the last term, sine of the middle term, quantity squared. So we have 4 times x minus 2 quantity squared plus 9 times x plus 1 quantity squared. And 11 plus 9 was 20 plus 16 is 36. Now we're not done yet for standard form because it must equal 1. And the way to make it equal to 1 is to divide everything in sight by whatever this number is, which it's 36. 9 over 36 reduces to 4 over 36 reduces to 1 over 9. 9 over 36 reduces to 1 over 4. And 36 over 36 is 1. So we took our ellipse from general form, put it in the standard form. That's the only thing that's new for today. Everything else we did in standard form, so let's quickly go through that. If we look at the larger denominator, that's under x, so it's a horizontal ellipse. The center is positive 2, negative 1. A is the square root of the large denominator, 9. That's under x, so that goes left and right. 3 to find 2 of the 4 vertices. B, the square root of the small denominator, is 4, so that's under y. We go up and down 2 to find the other 2 vertices. And as we calculate those vertices in our head, going left 3 is the point negative 1, negative 1. Going right 3 we add, that's the point 5, negative 1. Going up 2, we're going to add 2 to the y value, that's 2, positive 1. Going down 2, we're going to subtract 2 from the y value of the center, and that's 2, negative 3. The distance from the center to each focus is the large minus small denominator, quantity squared. Square root of 5 is approximately 2.2, and we're going to go left and right. C goes the same way as A, and A goes the same way as my ellipse. To find those two foci, we're going to go left 2.2 from the center, right 2.2 from the center. So a little quick math work. 2 minus 2.2 is negative 0.2 for the x value, and negative 1 stays the same for the y value. Adding 2.2 to 2 is 4.2. Y value is still negative 1. Eccentricity for an ellipse is c over a. C is the square root of 5 over a, which is 3. And since we graphed in our previous lesson, I think we'll pass on graphing for today. And so other than graphing, that's everything there is to know about an ellipse. Taking it from general to standard form, did everything but graph. Let's look at one more ellipse. Again, we know it's an ellipse when every term is on one side, 0's on the other. The coefficient of x squared and y squared are same sign, both positive, different numbers. Let's group all the x's together, all the y's together. To complete the square, we're going to take the constant, move it to the other side by subtracting. We have to factor out the 9 from all the x's, so we'll have a coefficient of 1 inside the parentheses. So that's 1x squared plus 6x. We have to factor out the 4 from the y's, so that leaves me y squared minus 2y. And it's time to complete the square. So 6 divided by 2 is 3. 3 squared is 9. This 9 is being distributed by a 9, so we're adding 81 to both sides. Complete the square for y. 2 divided by 2 is 1. 1 squared is 1. 1 times 4 is 4. We need to add 4 to both sides of the equation. We did already on the left. We just need to do that on the right. Don't forget, or you're going to get some strange numbers. All right, factoring our perfect square trinomials, we got x plus 3 quantity squared. We have y minus 1 quantity squared. Negative 49 plus 81 plus 4 is 36. It must equal 1. So divide everything inside by 36 to get it in standard form, so it will equal 1. 9 over 36 reduces to 1 over 4. 4 over 36 reduces to 1 over 9. It's just coincidence that they were the same numbers. All right, so the large denominator is under y, so that makes this ellipse vertical. The center is still negative 3, positive 1. A is the square root of the large denominator, so that's 3. That's going to go the same way up and down as the ellipse. B is the square root of the small denominator. That's going to go perpendicular, or left and right of that. And going up and down 3 and left and right 2 are going to help me find my 4 vertices. So let's add 3 to 1 to go up, subtract 3 from 1 to go down. That's negative 3, 4 going up, and negative 3, negative 2 going down. Left and right, we're going to add and subtract 2 to the x value. So subtracting, negative 3 minus 2 is negative 5. Going to the right, we're going to add negative 3 plus 2 is negative 1. Those are my 4 vertices without looking at the graph. Distance from the center at each focus is large minus small denominator quantity squared. Square root of 5 is still 2.2. C goes the same way A goes, and that's cool. Gotta love that AC on a hot summer day. And that goes the same way as your ellipse, which is vertical up and down as well. So let's find these two foci. Let's add 2.2, subtract 2.2 from the y value of the center, and that'll give us the two foci. So adding 1 plus 2.2 is 3.2. Subtracting 1 minus 2.2 is negative 1.2. Those are my two foci. Eccentricity is C over A. So we're going to go exact here. C is the square root of 5. A is 3. And other than graphing, that's our second look at ellipses.